I thought I'd do a quick little Excel demonstration, well, LibreOffice Calc, of why sine squared plus cosine squared equals 1. Or not why, but a demonstration of how it works. So what we're going to try and do is use Excel to set this equation up for different angle measurements and then see how this formula gives us 1 every single time. So the first thing we're going to do is we're going to put an angle measurement of 1 in this box. And one thing you'll learn about Excel is when you put something into the first box, if you highlight it and then click and drag this little square in the bottom right corner, when you pull it down, what it's going to do is it's going to extend whatever you have in that box, but increase it by 1 each time. Now, we want to make column A angle measurements. And then we want to take the sine of those angle measurements, the cosine of those angle measurements, and then add together the squares of them and see whether or not we get 1. All right, the only problem is Excel and most places that work with trig functions deal with radians. And you'll get a little bit more information about the difference between degrees and radians as you move further in math, get into pre-calculus courses. But what it means for us is we need to convert our angle measurements into radians so that Excel calculates the proper sine and cosine of them. And there's a function for that in Excel. And it's just set this box equal to radians. And what we want to do is we want to take the radians of whatever is in box A1. So A1 refers to the top left box. If we do that, it gives us that value. So an angle measurement of 1 degree is equal to 0.017453293 radians. Just like we did with degrees, we can pull this down and it's going to convert all of our angle measurements into radians. Notice on the equation line just above box B, this says equals radians of whatever's in cell A2. And then this is whatever's in cell A3, A4, A5, and so on. Okay. So now we have our radians. What we need to do is take the sine of that angle measurement. So I want to take the sine of the radian measurement that's in cell B1. We also want to take the cosine of the angle measurement that's in cell B1. So here we have C. This is the sine of this value in radians. And this value in radians we found by converting this degree measure into radians. If you want to check that this is in fact what you get when you take the sine of a 1 degree angle, you could pull out a calculator and do that now, just to double check. Okay. Now what we need to do at this point is we need to square our sine of angle measure of degree measure 1 and our cosine of an angle of degree measure 1. Okay, so all we're going to do here is we need this box to equal the value that's in C1 squared. So now it's going to square what's in C1, and what's in C1 is the sine of angle 1. And then in box F, we want to have this equal to whatever is in box D1 squared. So now we see this is an angle of measure 1. This is that angle converted to radians. This is the sine of that angle, the cosine of that angle. And now we have squared the sine, squared what was in C1, and we have squared the cosine. So what we're testing is to see if the sum of those things equals 1. So in this box, we want this to equal the sum of the things that are in box E1 and box F1. This should add together box E1 and F1, and we get 1. So that tells us this does work for an angle measurement of 1, but we want to see if it works for all of the angle measurements. So if I highlight these 5 boxes, I get this little black box again. We can drag it down, and it's going to extend all of our functions all the way down as far as we drag. We go down, And we notice that so far all of them equal 1. We could go further than that. If we want to know whether or not all of these work, let's go all the way to 180 degrees. So we're dragging down, our box is down, we're passing 90, all the way down to 180 degrees, and we just want to see that it works for all of them. Sure enough, it does. Every single angle measurement converted to radians, taken the sine, cosine of, squared, and then the sum of the squares of those angles equals 1. So maybe we haven't proven it yet, but we've at least demonstrated that this trig identity does in fact work for every single angle, integer angle measurement from 1 to